In this video, we're going to be looking at how we can find the area between two curves. So we've looked at in previous videos how to calculate the area between a curve and the x-axis and looking at how to solve definite integrals. So you need to be able to use this knowledge. However, now we're going to look at a scenario where you have two different functions and you have to find the area between the two functions or between two functions and an axis, depending on what the question asks for. So begin with two functions look like this. Above the x-axis, so we have the blue line, so we can call this, let's say, fx, and you also have the orange line, fx, and the blue line, gx. And what about if we wanted to calculate this area here? So we don't want to calculate the whole area underneath as well, but just this middle bit. So what we can do is we calculate the area between, we'll call this point B, so that corresponds to the x, and we'll call this point A. So if we want to find this yellow area, then we can use the fact we can calculate the area beneath the blue and the orange curves. So firstly, the blue curve. When we calculate the area underneath the blue curve, we're going to get this area here. Then when we calculate the area under the orange curve, we're going to get that blue area, but we're also going to get that yellow area. So what happens when we get that orange area? So the orange area minus the blue area. So the area of the blue. So what happens then is we're going to get this yellow area because the blue is just the blue area, the orange encapsulates the blue as well as this yellow bit, the bit in between. So therefore, if we calculate the orange area and then we subtract it from the blue area, we'll get the yellow area. So whatever the blue is, so it's going to be BA fx dx, and at the moment it's above the x-axis, but we can always just take the modulus just in case, and then minus that from the modulus of BA gx dx, and that will give us the yellow area and the area between the two curves between B and A. So that is when one, so fx in this example, is always higher than gx, and we can use that method and when it's above the x-axis. So what about if it's below? So if you still wanted to find this yellow area, let's say between 2 points, so B and A, however now blue, when we calculate the area of blue, we're going to get all the area. So we need to calculate the blue area and then minus it from the orange. But because it's negative, so because fx is less than 0 and gx is less than 0, then when we calculate the area, we definitely need to put the modulus signs in. So it's going to be the modulus of BAF, or we'll call it GX because we said GX last time, modulus, and then minus the modulus of BA FX, so this one is here, it's FX, DX close modulus. And that will give us this yellow area, so the area between the two curves. So now if we want to find the area between two curves, however, we've now crossed the x-axis. So we have to do this a bit differently. So we have to think, we want this yellow area in between these two. So when we calculate the orange area, we're going to get, so we'll focus away from this point at the moment. So if we're going to get this orange area, we'll get all of this area here. So all of that, all of that, all of that. And we'll also get this middle bit here, but we don't want that middle bit. So we're going to get that middle bit. And then when we calculate the blue area, we're going to get all this area here, and then also this area here, but we don't want that bit. So how can we calculate the area without those two bits here, without this bit and without this bit? Well, what we do is we just calculate the orange area, but we find the integral between, let's say this is x is equal to b, and x is equal to a. So we get, so once again, orange is going to be fx. So we get b a fx dx. So what does this tell us? Well, it's going to be positive all along here. So this area here is going to be positive. So we've calculated all this area. However, this bit here, this small bit there, is actually going to be negative, and that's because it's below x. And what we normally do is we normally split it up, but this time we're not going to do that. So we're going to leave it so this area is now a negative. Then when we add on to the blue area, we're going to take the modulus of the blue area. So we're going to go plus the modulus of BA GX dx. So that means whenever we find the area, and that's going to be negative, and then plus this positive bit. So effectively what we're now doing is we're going to take away this area. So this area is now going to be taken away here from this blue bit. And that's because normally it would be positive, but because we have this negative and then we're adding the positive, it's effectively taking it away. And a way you can think about that is we're taking the negative instead of the modulus. Then this bit down here is negative, now it becomes positive. So we're going to add all of this bit down here. And we're also going to add this little bit down there. But remember before with the blue, we took it away. So that means if that, whatever area that is, it was counted in the blue and then subtracted from the orange. So we don't include that area. So we've calculated the area between the two curves between x is equal to A and x is equal to B. Think about that. We've got the orange area and then plus the modulus of this blue area. And if you don't understand that, it is a bit confusing, but go back, look at this diagram, think about what does this area tell us. Remember that this is going to be negative. What does this blue area tell us? You can split it up into the two and you'll see that the positive actually gives us a negative answer. You can think about it just instead of the modulus as negative BA GX dx. So what about this graph here? So this one is when we wanted to calculate, we'll say we want to calculate between, that's straight, this green line here and this green line down here. So if we wanted to calculate between x is equal to B and x is equal to A, so we want to get this entire area here, then what we need to do is we need to split it up. So firstly, you can work this bit out yourself. You can split that up and then you work this bit out as well. So when they intersect, it's always a good idea to split them up into different parts. So when we calculate the area between graphs such as this, we'd split up the under, the over bit, and then over and the under into the 4 different sections. So with this bit as well, you can calculate this area like we've done previously, and then this area using another method we've done previously. But together, they may be quite hard, so it's always good when they intersect to split them up. So now we'll move on to a question and we'll go through an example. So question, find the area between y equals x squared minus 16, y equals negative x squared, x equals negative 2, and x equals 2. So the important thing here is that the axes are not mentioned. So if the axes are mentioned, then we can calculate them like we've done in previous videos. However, as the axes are mentioned, we only look at these lines when we want to know what area we want. So first we have x squared minus 16. So it's going to look something like this. Then we have negative x squared, so it's going to look something like this. X is equal to negative 2, and x is equal to 2. So the main thing I want to check is x equals 2 and negative 2 closer than this endpoint or further away? So to find the intersection between two graphs, you let them equal. So x squared minus 16 is equal to negative x squared. 2x squared is equal to 16. X squared is equal to 8. X is equal to plus or minus 2 root 2. So square root of 8, take the 4 out, 2 root 2. And now 2 root 2 is bigger, in terms of magnitude, is bigger than 2 and negative 2. So that means this negative 2 and 2 are going to be two lines that come down like this. Now what's the area we're looking for? We're looking for this inside area here. So how can we calculate that? Well, we get the graph that's lower. So at this time that is y equals x squared minus 16. And we calculate that area there. Remember using the modulus because it's a negative. And then we subtract it from this area here because this purple area will give us this area. So when we calculate the orange area all the way down, subtract the purple area and we'll get this yellow area in the middle. So with regards to calculations, we can calculate the yellow area. So area yellow is equal to BA fx dx modulus. That's really important you put the modulus there. minus the modulus. So not minus a function. So this minus is due to you want to get rid of this pink area. But you want to put the modulus there to make this pink area positive. Be a gx. So fx. So fx is referring to x squared minus 16. And then gx is in reference to y equals negative x squared. Dx close modulus. And b and a in this term is going to be 2 and negative 2. So solving this, we're going to get 2, negative 2, then x squared minus 16. So x squared minus 16 dx. Take the modulus of that, subtract it from 2, negative 2, negative x squared dx. Once again, taking the modulus of both of these. So it's really important you don't forget these moduluses. And you're going to get the answer 160 over 3, but to get this, it's 176 on 3 minus 16 on 3, which will give us 160 on 3. And if you're talking about the area, that's going to be units squared. So finally, just before we finish the video, what about if we want to find this area in between the graph and the y-axis? So if you wanted to find this green area, one way you can do it is by working out this yellow area. So you should be able to work out the yellow area. We've done that in previous videos. Then realizing this is a square. So you work out what this length is. So that is the point, let's say, well, this is the point AB, and this length here is going to be A, and that height here is going to be B. So then the green area, area green, is equal to B times A minus the yellow area, which we'll call C. So you make it a square, subtract the area under the graph, and you'll get the area between the y-axis, this line up here, and the function.